Hello everybody, welcome back to Pluty2 Plays, and this is another educational video of SpaceEngine. Yes, let's get right into it. So, in today's episode, I wanted to really focus on planet Earth, Mercury, Venus, and Mars. Well, in general, I wanted to focus on the solar system, but I think as far as we're going to get today is within those 4 planets. So we're going to start at our very own star. Our star is a beautiful main sequence star. It's considered a yellow dwarf, and it's just everything that we know that provides us energy. I apologize for the video today for I am a bit intoxicated, but that's okay. As you know, if you can see my mouse here, there's 13 planets. Well, there's 8, but this counts some dwarf planets, including Pluto, one being with life, and I think we know which one that would be. Our star equals to about 5,778 Kelvin. You can say it's roughly about 10,000 degrees Fahrenheit on the surface. And as you know, it provides us with everything that we are and know, because it is our star. That's why there's a cliche out there that we are star stuff. We have come from the supernova of a dying star. So we'll go ahead and move on to the first planet within our solar system, and that would be Mercury. And even though that, yes, this is the closest planet within our solar system, this is not the hottest. Pretty warm though. It's pretty warm. It is still 130 degrees Celsius. That's pretty warm. I trust everybody would at least be smart enough to do the conversion. I'm not saying that because I don't know the conversion. I do. But we'll leave this for more mature audiences. And although you could look it up on Google, right? It's not that hard. So yeah, its gravity is about, it tells us right there. So 0.37. So it's a little over a third of our planet, and we're gonna go ahead and dive in. Let's dive right into the planet, right on the surface. And we'll let this son of a bitch render in. I know it looks bad until we finally land. Here we go. We dove right in there. So let's go ahead and dive back out so we can dive back in. So we dove right inside. As you can see the crater. We dove right into the crater. We're on the edge of one of these craters. It's a very cool rendering game. I like it. I like it because it could be very educational. So as I said, this is the closest planet to our star, and I think it's one of the more moon-like planets. I mean, if you're going to think of a planet that looks like our moon, you're going to say Mercury. And as I said, it's very close to our parent star, which is the sun. That looks pretty. Venus is the hottest planet within our solar system. So we will go ahead over there and we will check her out. Bunch of clouds. It's still a solid planet. It's not a gas planet, but it has a lot of gas within its atmosphere, which makes it like a gas planet. So we will zoom on in. Again, it is the hottest planet. Its greenhouse effect is very high. It has CO2 and N2. It's very old. Not that much older than our planet, but its solar day is 8.1 years. So a day on this planet is 8 years on Earth. How about it? So it don't spin much. So let's go ahead and speed it up and see if we can get a spin out of it. 300 times. Oh, no, 30,000 times more. So for one spin, there's almost a year. It just doesn't show it within its spin, but that's okay. We will enter within the planet. Here we go. We're in. Now it's very hot. Now where we are relative to the average temperature of the planet, the average is 516 Celsius. Where we are right now is 457 degrees Celsius. And this is the planet of Venus. And it's funny because it looks quite similar to the actual picture that was taken on the surface of Venus. So if you go ahead and want to go onto Google and type in picture on Venus surface, you will go ahead and see this. Something just like this. The sky would be the same. Very, very detailed. very detailed, I'd say. We're gonna go ahead and come on out. There we are. Let's go ahead and go to Earth. And I think we know a lot about Earth, don't we? Here's our beautiful planet. The solar day is 23 hours, 59 minutes, and 59.98 seconds. When we sped up Venus, its spin didn't represent what we were seeing on here. So obviously we all know what Earth looks like. Earth is Earth. Earth will always be Earth, and that's how it is. That's what we see when we're on the planet. No, it's a space game. It has, you're literally traveling beyond the observable universe in this game, so they're obviously not going to detail Earth with cities and all that crazy shit. Our greenhouse effect is 33 degrees Celsius. We have obviously one moon. Our average is 14 degrees Celsius, one atmosphere. We have nitrogen, oxygen, and argon. Now our C composition is H2O, NaCl, which is water and sodium chloride, which is salt water. Our gravity is 1g. That's how we measure. 1g, 1 gravity is 1 Earth gravity. So if you have a planet and it's 2 g's, it'd be 2 times the gravitational force of Earth. Our age, 4.5, 10 to the 9 years, which is 4.5 billion years. We have about a 23 degree tilt on our axis. The mass is 1 m, which is 1 Earth mass. We're a temperate marine terra with life. We also have marine and terrestrial. It also should say aerial, or because we're an organic multicellular. So, but we have fish, which would be marine. We're walking around the planet, so are all the animals and mammals. So that would be, terrestrial. And we have birds, and we have. I suppose you could say birds are terrestrial. They're not just in the air. There's not life specific only to survive in the air. So you could say that, but just because it flies, I guess it don't mean it's an aerial form of life. And now we're gonna go to Mars. Here's Mars. I want to go to the Mars moons though. Phobos. It is Phobos. Okay, I thought so. And how did I think so? By its shape. I will say I thought, but the shape of Phobos. No, it's just a small rock. It's not. It has barely any gravity, as you can see. Remember, 1 gravity would be an Earth gravity. So if that was a 1, that would be the gravity of Earth. So look, it's 0.0006. It's very, very weak. If you fart, you would take off into outer space. It's cold. 7 hours of spin. It seems that the spin represents the actual planet. So I like that. Go to Mars's other moon. Very small little guy. It's only Phobos. This has more of a distinct shape, but it's not as rocky. Depends where you are, I suppose. Within the moon itself. See this right here? Look at my mouse. See with it? I love looking up at the sky at that. Pleiades. We'll have to go there. Of course, Taurus. Pleiades is in Taurus. That's my sign, by the way. I was born in April the 30th. We'll go back here, and we will go to the planet of Mars itself. Mars is quite something, I tell you. It's 2 moons, obviously. It's 5 degrees Celsius. Its temperature is negative 67 degrees Celsius. Its atmospheric pressure is very weak. It's 0.012. So, again, we measure by Earth's atmosphere. The sea level on planet Earth is 1 Earth atmosphere, 1 atmosphere. There's CO2, argon, and nitrogen. Its gravity is 0.3, so it's about a third of Earth's. Again, it's about 4.5 billion years old. It's 24 degrees tilted on its axis. And it is 24.5 hours for it to be a day, although we call them sols. Tad bit longer than Earth. The planet spins slower. So we'll go down here into these little craters. So this is one of the crevices, ravines. It's a beautiful planet. I hope I'm alive to see us go to Mars one day. That'd be amazing. At the end of this episode, I'll probably bring us somewhere cool. I want to make this a 2-part series. What I'm going to do is I'm going to leave it here on Mars, and we're going to go somewhere in the second part of the series. We're going to go somewhere outer space too. I was looking at Pleiades, so why don't we go to the constellation, or the cluster, I should say, of Pleiades, which is in the constellation of Taurus. Very, very far away. Light years away. If we go back here to the sun, we'll look back up at Pleiades. From Mars to Pleiades, we are 365 light years away. That means that it takes light traveling at 186,000 miles a second, or 299 million meters a second, for something that takes 186,000 miles a second. So think of it, the Earth is 16,000 miles to do a loop. Do that 7 times. And it takes light 1 second to loop around the Earth 7 times. The speed of light, which is considered the cosmic speed limit, is 186,000 miles a second. Traveling that fast, it still would take light 365 years of our years to reach Pleiades at traveling at that speed. So technically, us standing on planet Earth, when we look up at the cluster Pleiades, we are looking at 365 years into the past. And it's quite cool to think of it that way. So let's go ahead and travel to the Pleiades ourselves, because I think it's cool to do it that way. Now this is something too, right here. This is a constellation itself. But we're not going there. We'll go there next time. If not, we'll go somewhere else. But this is... we are traveling up, and we are getting closer to the Pleiades. Which is a star cluster. So we can look at certain other stars within Mercury. Okay, so we'll go to the object star itself. This star itself has 7 planets. So we're going to turn this down, and we'll see that it's a blue star. It's a blue subgiant. So it's not a supergiant, but it's still very, very bright, hot star. Oh, that was one of its planets. So we'll go look at the planet of Mercury 2, which is the planet of the star Mercury in Pleiades. Look at the moon. So many moons that this planet has. We can see how they orbit this planet. Wow, that's something to be... That's cool. That's something to behold right there. So we will slow her back on down. We'll go over here, slow it down, and then we will fall within the planet itself. Here we go. That's something. Although that's just one planet of the star of many stars within the cluster of Pleiades. This we have a triple. I didn't know that there was a triple. Speed up. I want to see them orbit each other. Where's the triple? I guess there ain't a triple. Well, maybe there is. Maybe there's a small one that's orbiting within one of these two. Anyway, that'll do it for this quick but educational video of SpaceEngine. I really enjoyed these episodes. Again, I was supposed to have a better quality mic. I found out that the mic was malfunctioned. It was a blue snowball ice microphone, and it sounded so much better. But unfortunately, when I moved it and shook it, there was a piece loose in there that made the sound very staticky. So it was malfunctioned, and I couldn't use it. Therefore, I'm gonna have to bring it back, and so we're gonna have to deal with a few more episodes. The regular standard computer mic. We'll get a better quality mic. Check out this cluster. Holy shit, huh? Wow. Man, we're gonna have to check out one of these next one of the episodes. That'll do it for this episode. I hope you all enjoyed, and I hope that you had a very educational video. And I will see you in the next one, and I'm excited for the next one. This has been Pluty Plays, and we have been playing SpaceEngine. And I will catch you all in the next episode.